What's up, Kyle gang? Welcome back to some dynamics. So let's solve this problem. Let me get this chair out of your way for you guys. So we have a mass of 2 kilograms. It's this particle here. We're in the xy plane. It has a velocity of 10 meters a second, acting at this 3, 4, 5 triangle. So our goal is to find the angular momentum around point O, which is this origin here, which we'll label that. Okay, so let's go ahead and do that. So we're going to use this one equation here. Angular momentum is equal to the cross product of radius times mass times velocity. So really simply, we can factor out the mass, and we're just taking a cross product. So cross product, right, we set up our little table, ijk, and so radius is going to go on the next line. So we need the radius to the line. So our radius, if you're going to draw it here, is going to be this vector that goes from the origin to our particle. Now obviously, we can tell that its x component is 4 meters, its y component is 3 meters, and we're not in the z direction, so we can have a 0 there. So then finally, velocity is the the velocity component, right? So we have 10 meters a second acting at this 3, 4, 5 triangle. So really quickly, let's solve for what that velocity vector is going to look like. So we're going to take 10, and then we need to multiply it by the ratios. So in the x direction, it's going to be 3/5. And then, so that's I. And then in the y direction, it's going to be 4/5. So 10 times 4/5. J. Did I do this right? So this gives you is equal to 6i plus 8j. So that can go right in there. 6, 8, 0. So now it's just about computing this cross product. So let's go ahead and do that. So if we look in the I direction, it's going to be 3 times 0 times 8 times 0. Obviously, going to be 0 in the I direction. So we're going to get 0i. And we're going to subtract j. 4 times 0 minus 6 times 0, it's going to be 0 again in the j direction. And then finally we get to z. So we're going to take 4 times 8, so that's going to be 32. And we're going to subtract 6 times 3, which is 18. All right, so then you do this, and you get that the magnitude, or this vector, is just equal to 14 times mass in the k direction. I don't know why I wrote a j here. But yeah, that's supposed to be k. All right, so this is a k in the k direction. So then all we need to do is multiply by mass, that 2 kilograms. We're going to find that the magnitude, because obviously it just acts in one direction, the magnitude is the same as the k direction. We're going to get 28 kilogram meters squared per second. And there we go, that's how you solve this problem. So not too tricky. Just about taking that cross product. We're going to do some more complicated problems next, so feel free to check out those. I'll see you in the next video. Peace.